Hey, Carrie.
Hey, Jenna.
Good to see you today. I'm excited about this bite because the activities in it, while they are specific to Valentine's Day, they can be used for like any like big or small holiday. Like these could be geared towards Groundhog's Day in a few days, or a topic or content that teachers are doing in their classroom throughout the school year. So it's a lot of fun, and I'm excited about this bite today.
I can't wait to put together.
Yeah, as we get started, if anyone has been previously watching or looking at the bites, I do want to let you know we have restructured some of it so that it should hopefully feel and look nicer and easier for you to navigate and get to where you want to be faster. So we had kind of gotten some feedback that you had to scroll a little bit to get to the content. And so we've gotten rid of that scrolling. And right now, we're telling you what's in the bite at the top, and then right away we give you the quick links to get to the activities. So once we're done with today's webinar, we will link it in this document. But the first activity is using microbits to create a flashing heart, or whatever the student wants to make. So if you're not familiar with microbit is a small little microcomputer that you get to program, and it's a pretty easy block-based programming language and it's an intuitive block-based programming language that you program on the computer, and then you connect your microbit to a cord, and you can move the program over and make it work on that like actual device itself. If you do not have microbits in your classroom, that's completely okay, because they have a really great simulator that does exactly the same thing. And so I just want to showcase that simulator. Carrie, I know microbit is one of your favorite products out there for computer science. So you're not going to have many questions, but I do want to show this to everyone. So right here, I have this every 1,000 milliseconds switch between the big heart and the little heart. So it's kind of like a beating heart. And then I created these as example GIFs that I put into the bite itself. But I also have this over here. So, this is a heart that's moving up and down. And then here I have I heart you as the images. And so it's a really nice, easy way where the microbit itself has a 5x5 grid of LED lights, and the students can turn them on and off and animate them. And so it's one of those like really nice, easy, quick wins for students to understand that what you put into the program is what's going to come out on either the device or in the simulator itself. And so like I can show you, like if I want to make this a weird OI, and then when I hit play again, it automatically updates it quickly. So it's a fun, quick win. I have done this with students as young as kindergarten and as high as high school. So it's really accessible. It gives them that autonomy to get their ideas out of their brain and make it work. Especially when, if like for the younger kids, you can say, okay, we're going to just switch between two, and you can show, right? You can show this code on, like you can present this code on your screen, like your school screen, and they'll be able to pull in the blocks onto their computer, and then they get to put in whatever LEDs they want. And so again, it's that like quick, easy win where students get excited that they created something and it looks really cool and fun. Also, there is a LED planning sheet from Microbit that's nice and easy. So we just linked to that. It's downloading it, but it's literally just the 5x5 grid, and the students can figure out what they want to show and not show. So that's that for this activity.
Jenna,
yeah.
Can we go back to make code? And in case students, teachers want to have students go through it, there is a tutorial.
So I've actually linked that. That's this main lesson activity. it's called Beating Heart. So that's the one where it's like the big, small, big, small. And it actually, thank you for saying that. It walks you through coding it and what you want it to do. And so it's a tutorial. It shows you like a short video on what it is, what you're going to do, what you need, and then how to do it.
And there's one other location. Click on the tab.
Which tab?
That make code.
This one.
Yep. And then the microbit logo.
Oh.
And that flashing heart in the second row, the first one.
Oh, that's a new, that wasn't there when I made it. Great.
So then when you click the block start tutorial, what's really cool about these is it chunks it for your students. So hit OK. And then the information is all color coded to show you what menu, and it takes away any distractor blocks from the toolbox. So if you have a student who may like get overwhelmed with the amount of options, any of the tutorial options only show you the blocks that your students need.
That's awesome. Thanks for pointing that out. I did not.
Click on the little light bulb. It'll show you the answer per level. So if a student maybe struggles at reading, it can read to them and then visually show them the process as well.
Sweet.
So you've got a couple of other resources on there if you're a new to microbit teacher as well. And it kind of just goes through. And so your students aren't penalized for exploring, and you don't have to hover every step of the way for them. And then once you do that step, you could hit next. In the instructions, like I said, Jenna, you see the little read aloud. There's a read aloud button if your students needed that. And then for every chunking statement, it shows them the new answer in kind of GIF.
That's amazing. Thank you, Carrie.
You're welcome.
I love that. Yeah. So again, that makes it even easier and accessible for those younger grades and the students who definitely need more support. They have lots of support options in their tutorials. Their tutorials in general are amazing, but I didn't know that they had done this for the beating heart one. So that's awesome. Or I guess this one's different. It's a flashing heart. It's just it's on, off, as opposed to the small, big. But that's awesome. Thanks, Carrie.
No problem.
So again, it's nice to like give students the autonomy. If they don't want to have a heart, they can say, I heart you. They can say, will you be my Valentine? Like whatever they want to do, whatever level of detail and like excitement they have in it, right? So if a student comes across like the sound and they want to add a sound when you press a button, like let them play and explore. But the main point of this is just to like get that quick, easy win of like 2 or 3 different LED displays that you're switching between. And then we have the highlighted computer science standards like we've done in all the other activities. Okay, any other questions? I know you just showed us that really great tutorial, so that's amazing. Do you have anything else you want to point out or talk about with this?
No, I love this, I think. And like you said, once your students figure out the lights, then you can do this for anything. Any other option or any integration touch point that you can think of, they can create a 5x5 grid of lights to just turn on and off and make an animation to support it.
Yep. If they have any project that they want to have display, if I know like your son had like for a costume he was wearing, he had like he was displaying something like his name tag, right? So or if students are doing like a science fair project, they can have stuff display. So it's really great and easily accessible once they get that first one down. Okay. So the second activity is decoding binary Valentines. So for those of you that aren't aware, binary is how computers communicate with humans. So when we type on our computer, when you type a capital letter A, when you hold down Shift and A, you're actually sending zeros and ones to the computer, and it says, oh, you want me to display a capital letter A. And that's what's happening. And so in this activity, we're using that binary, those zeros and ones, to have students make encoded messages for Valentine's Day. Again, Valentine's Day is just like the thing that we picked, the generic holiday that we picked, but you could use it for any holiday, any topic, any lesson. So we have this blocked into, actually this is supposed to be K2 supplies, K2 supplies and 312 supplies. So K2, what we do is we use 1x8 grid of like 8 squares, and we highlight them. They're either black or they're white, and that's the code. Again, younger students are really understanding patterns, and this is a really great way to help solidify pattern understanding with those students. So K2, we're using blocks, and then in 312, we're actually using the true binary value. So that's the zeros and ones for the character. Now, as you will see in this conversion chart, so for the younger kids, all I do is I give them the capital letter alphabet, and I give them 4 special characters. I give them an exclamation mark, a question mark, a period, and a comma, because I don't want to overwhelm them with everything. As your students get older, they're going to ask you all the questions and all the things. And so I've given you more information. I've given you all the uppercase letters. I've given you all the lowercase letters. And then on the second page of this chart, I've given you all the special characters. One thing I do want to highlight for you, I've put it in multiple places within the byte, but a space in binary is not just a space on the space bar. You actually have to type in 0010 0000. So it has to be those 4 or those 8 zeros and ones in that combination. And that is, again, if I type space on my computer, that is me communicating with the computer using zeros and ones, that I actually need it to put a space there. Computers don't understand spaces between zeros and ones. So if you do 0 space 0, 1 space 0 space 0 space 0 space 0 space 1, it's the same as just having it all together clumped or putting like tabs and stuff in the middle. You actually need to put those spaces. So anyhow, so we have these conversion charts to help your students. I would recommend printing these out for each student so that they have it at their desk readily available. And then I've created class slides demonstrating how this works. Now, slides 2 through 7 are intended for those younger grades if you're using the shaded squares. And then slides 9 through 13, I believe, are for the older grades using the zeros and ones. And so what these slides do is we say, okay, this is actually, let me see. I'm going to see if it will share. Okay, yeah. So it says, how can we figure out these words? And so you as the teacher are going to say, we're going to look at what this pattern is. It's black, white, black, white, black, black, white, white, and see if we can find it over here. What we say is, oh, we found it over in the S. And so I've highlighted that for you. I've animated this slide for you. And then we would put the S in this column. And then we're going to go down. This next slide, we're going to finish decoding. So I keep the S there. And then you as a class can work on decoding this message. Just so you all know, this says secret code. That is also in the byte itself. It tells you that it says secret code, but just so you know, if you are an auditory learner, you can have that message right there. And you'll work together as a class to do this either on a smart board, or you can do it, you know, as a class, figure out what the letter is and write it down on like your whiteboard, or they can write it down individually on their papers. And then we talk about exactly what I told you, that computers work based off of little pulses of electricity. These pulses are binary. And so it's like a light switch. And so this is a good way for students to remember the zeros and ones is if you have the light switch up, that's 100% of the electricity going to the lights. The room is bright and white, and that's a white square. And then if you turn off the lights, the room is dark, 0% of electricity. There's no electricity going to it, 0. And so a 0 is a black square, so it's dark. So just for students, if they're trying to understand, like, what does this have to do with computer science, I've given you these 2 slides. You do not need these 2 slides. There's slides 5 and 6 to do these activities. It's just, again, if you're trying to really connect to the computer science, I've given you that information. And then this shows students that the letter A in the code you all have is the black, white, black, 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 white. but in binary, that's the 0, 1, 0, 0, 0, 0, 0, 1. And so that's just showing them that this code is true binary, truly how computers communicate with humans. And then for those, the older kids who want to be working in the binary, again, it's that same message, secret code, but using zeros and ones this time. And then the cool thing is I've shown you that the conversion chart, this guy that you're using, that you've printed out for them, if you go to Google, so I just shared a Google search with you where it says binary character table, you can click on any of these and it will show you the same zeros and ones. So here's like, over here where my mouse is a capital letter A, and it's telling you it's 0, 1, a whole bunch of zeros and ending in 1. That is the same thing that's here, 0, 1, a bunch of zeros and then ending in 1. It's a capital letter A. It's the true binary representation of the capital letter A. And so you can do that for, again, if you're not going to necessarily do this with a 3rd grader, but if you're teaching 11th graders, 12th graders, it's a really great thing to like show and prove to them that it's the true binary representation in computer science. So that is the first part of this activity. Carrie, do you have any questions or thoughts on it?
No, but what I love about those slides is those slides are, the teacher wouldn't have to do any work to use them any other time of the year. They're
Right.
not specific to Valentine's Day with the message of secret code. They could pick up just that introductory content and do it at any time.
Yep, exactly. Yeah, and then thank you for saying that, because it's not Valentine's specific, and I did that intentionally. So what I've done now is I've given you words to decode. So we've got words that you can give to your students, and now they're decoding these, and these all are specifically Valentine's words. So if we scroll down to the Valentine's exemplars, I have to update this, it got cut off, but it's love, roses, hug, and you'll see all of them are the capital letters for those younger grades, because that's all I've given you in the conversion chart. But for the zeros and ones, we've got capitalized Cupid, but then heart is capital H, and then lowercase rest of the letters. And then here again is my note that spaces are that 0, 0, 1, and then all zeros. So that is that for that first activity. Then I have a second. If the students are loving this, they want to keep going, they've gotten the like hang of decoding the messages, they can actually encode and make their own messages in a Valentine's Day card. So I'm going to actually close out some of these tabs. And then, so I've done it for shaded squares, and I've done it for the zeros and ones. They're identical. You can switch out if you want to make a copy of it and switch out whatever the image is, but it's that quarter fold, so they can like actually make a Valentine's card. And then I give them their chart on the left, and then they can say who this message is to. They can write out their code over here on the right, and then the person who receives it would be decoding the message, right? So they encode it. So this is the zeros and ones, and then the same thing is the filling in the blocks if they want to write a message. Now, the only thing I didn't do, and this is just because different people think differently, is you can either go that first row, first letter, second row, first letter, second letter, and keep going down. Or when I gave this to my own children, they filled it down in the first column, and then they went up to the next column, because they were like, well, it's a coded message, so it doesn't read necessarily the same way we read in English. I'm like, okay, but you're going to have to let people know that. And so my son actually drew an arrow from he drew an arrow down the first column, and then an arrow from the bottom first column row all the way up to the top one to point like that was what he wanted you to do. And I was like, yeah, and maybe when you hand the Valentine to your friend, you can tell them how they're decoding it too. So that's just a heads up that I didn't put that in there, because I was originally going to do it, and then the first person I tested this activity on did it differently than I was going to demonstrate it. So yeah, So I've given you 4 different pictures, but the conversion chart's all the same. And you could also even just delete one of the images and let the students draw their own Valentine on the front as well. Any questions about these activities, Carrie? The words?
No, I really like that. And I like the little remix on how you have the option to code it either left, right, or up, down. I think that was cool.
Yeah. So again, just voicing over that, because you never know. You never know what students are going to come up with. And then this is one of my absolute favorite Code.org lessons, that it's like a little gem that just lives within one of its elementary school courses. But the lesson itself is about me. And so the point of this lesson is to get students using computer science to tell others a little bit about them. And so the whole point is that it's like supposed to be like a little character or sprite that looks like the person. And then like when I've done it before, I had like a dog sprite and I had a computer sprite, and I told people that I loved computer science and that I love dogs. And when you click on the dog says, "Don't forget about the ice cream that you love," and an ice cream cone pops up. And so that's like the activity. And I have turned this into making it an interactive digital Valentine's Day card. And so I will just show you, if you're not familiar with Code.org, they have really great, well thought out lesson plans where it talks you through every single thing that you need to do. So there's an introduction, the main activity, they give you teaching tips, they tell you what you should show, what you should display, what you should say. It's very great, very handholdy if that's what you need. And then I've given you this example digital interactive card, which is one that I made. And so on the byte itself, right here under the exemplar, it tells you the instructions for demoing it to your students. But basically what you're going to do is you're going to click on the heart. It's going to say, "Will you be my Valentine?" And I'm going to say yes. And it says cool. And it starts wiggling. And the sprite costume changes. And then if I refresh this, so it's the same original link, it will go back to, it will reset the program for me because I don't do anything. Actually, that shows me that I should probably hide the yes and the no, but I haven't done that. But again, if I was debugging my program or displaying it, then I would be like, oh, that would be a good next step of something I can do. So if I click on it, "Will you be my Valentine?" And then if I say no, it's a broken heart and it says, "Ah, well," and it moves off the screen. And so that's something just really fun and exciting for the students, again, to have that autonomy to be playing with computer science and programming something, but it's not something necessarily really serious. And it's kind of like they can have their own fun and creativity with it without being specific to something they're necessarily learning in school. Though, again, you could absolutely do this. Like if you're learning about the Civil War, or you're learning about ancient Chinese civilizations, right? Like whatever you're learning about in class, you could have them animate a multiplication table, right? Like you could have them animate a ton of different things, anything truly you want for any holiday or any topic. But this was a fun, easy one to just demonstrate for students with Valentine's Day, especially if Valentine's Day falls on a Friday this year. So if the kids are getting a little antsy and you're like, okay, nobody's learning anything today, let's program some digital Valentine's cards. This is a really fun, easy activity for you to do. Carrie, any questions on this?
No, I love it. And I loved your interactive greeting card.
My demo.
Yeah, I think you can do so many things like with an interactive gallery walk for your students and let them play, even with yours as the starter, to say like, how did you do that? And kind of explore it.
Yep. And thank you for saying that. So I have 2 other things I want to show you. So on this, if you click on how it works, that's when you'll actually see the code. So you can show your students this code, and this is how I programmed it. Again, I would probably in here, when I say when yes is clicked, then I would probably also add the hide yes, hide no block, because then you're not keep clicking them, because you can still keep clicking them. But your students, if you want to use this for your students and give it to your students and have them click remix, it will make a copy of it and then they can edit it however they want. So again, if you're working with younger grades or students that aren't as comfortable with programming and computer science, and this is their first play with it, then you can give them this and they can say, okay, we're going to, instead of making a new sprite, this smiley face, I'm going to make it something else. And you can go to costumes and you can hit new costume and they can find, they're like, okay, when you say yes, I'm going to turn into an alien spaceship, like whatever, right? Like whatever the student wants to do. And then when they go back to the code, they're going to have to make sure that all of these are then the alien spaceship because it's no longer a heart with sunglasses. So it's just them kind of understanding it. Mine, I will say mine is pretty intense in terms of like the coding I did. I just wanted to show students that are excited about this and want to do more, that there is more they can do than just clicking on something. And so in the lesson plan, it actually steps them through. I'm going to click into the full level right now for code.org. Oh, no, it's showing my thing because I've done it all. So this is like the first one where Riki is introducing herself. And then because I've already done the levels and I've finished out my project, it's showing the full project. But if you go on to the second one, it's literally just saying, click the costumes and find your main person. And so my main person was a smiling heart. And so it just walks you through. It's a tutorial. It's not as like nice and easy as the microbit one was, the make code one was, but it's nice because it does tell you. So it says, go to the costumes tab and then look for the people category and find the person that you want. Because again, it's an about me, but it can be, instead of a person, it can be whatever sprite or character they want for their Valentine's card. So that's that. Then another thing I wanted to show you is the reason that when you click on my link, it looks like a miniature phone. It's because when I clicked share, I copied the link to the project, and that's what I shared with you, was I shared that link to the project. So if you have an LMS, you can have your students copy their link and put that link into the LMS, and that's what they're submitting to you. And you can either do like a gallery walk where the students walk around to the classroom and see each student's project, or you could present it up on your screen and you could have each student. So you'd be like, hey, Jenna, come on up and show us what you did with your project. Show us how it works. And then I would show it on the screen, but you would have everyone's project. And then this is really fun, sending it to the phone. So you could print out or have it like saved all the students' like parents' phone numbers. And you could be like, hey, we're sending you a Valentine's from your student today. Be on the lookout for a text with a link. And it would get sent to your student's parent, whatever phone number you put in. And they could get their child's work from your class. So anyhow, that's really fun. And then also I wanted to show you, I did create this rubric for this, again, for those older grades, or if you want to turn this into like an actual project. The only thing you actually would need to change is this Valentine's card. So it could be interactive digital, I don't know, solar system rubric, right? And everything else is just, well, this specifically says Valentine's Day, but I can change it so it's more generic. But it's a nice, easy way for students to get points and for you to be grading in what you're looking for in the project itself.
That's awesome.
Right. Yeah. Any other questions or thoughts on this?
No, you've given a lot of good options, especially like good ways to use the platform too.
Cool. Yeah. So anyhow, that's all I have. Like I said, I'm really excited about these 3 projects because they're very generic and not necessarily Valentine's. We just were excited to have Valentine's coming up and to do something again, because it's on a Friday and you might be looking for some activities to do late on a Friday afternoon with your students that are related to Valentine's Day. So that's all I've got for you. Until next time, have fun, enjoy your computer science, and we'll see you around soon.
And have happy Valentine's Day.
Yeah, absolutely.
Bye, Jenna.
Bye, Carrie.